All right, well, thanks everyone for joining. My name is Amber Roberts, ML sales engineer here at Arize, and I'm going to be talking to you today about ML observability. So on the agenda, we have the challenges with productionalizing machine learning models, kind of the four main pillars we see associated with ML observability. Then we'll be going into a demo of the Arize platform. The demo will incorporate all the things I've chatted about with performance, drift, data quality, and explainability. And there will be time at the end of each one of these segments to ask questions and questions before the demo as well. So a lot of us are here today because we know the challenges of taking a model from research to production. It's very difficult. These models tend to fail silently, and it makes them incredibly difficult to troubleshoot. Troubleshooting is a painful process because when we take a model from our Jupyter experiment environment and we put it into production, we don't know exactly what's going to happen. So what we see for the main pain points with ML observability, we see these across a variety of industries and teams, is model and data drift. So being able to try to troubleshoot that, performance degradation, data quality issues, and then also around explainability, model readiness, and fairness and bias. So when I say ML observability, a lot of folks think of ML monitoring. But a key thing here is that ML monitoring is just the tip of the iceberg when it comes to tackling challenges in production. Monitoring is a great first step to managing your models in production, but it doesn't really, get that root cause analysis, that troubleshooting workflow of figuring out why models are actually performing the way that they are. So needing ML observability, it will take you that step further and help you actually root cause and resolve the model. So the four pillars we're going to talk about today are performance analysis, drift, data quality, and explainability. We're going to start with performance. So it might seem pretty obvious that we need to monitor the performance of our models in production, but going beyond the metrics, like we're doing this for the KPIs, the bottom line, like for our business, because each one of these models can touch millions or billions of dollars in revenue every year. So even if your model is performing, 1% below what it should be performing, like that is very costly to the company. Take a recommendation system at Netflix, for example, that's $1 billion algorithm. So being able to optimize it and not just see when it's breaking, but understand when it's slightly underperforming in order to resolve it and ultimately help your company's bottom line. So we're going to start with models with fast actuals. So these are the type of use cases like click-through rate. If you're going to predict, whether or not a user would click this ad, you get that ground truth or that actual back fairly fast. So you're able to measure performance very fast in production. Challenges in production do include like trying to map back that actual with its prediction. Choosing the right success metrics for your model, and then also trying to surface up individual features or cohorts to analyze these predictions. So going beyond kind of the one performance metric, while you definitely need these performance metric monitors in place, just having an aggregate statistic isn't always enough. So you want to be able to surface up where your model is underperforming. So being able to have these metrics around every feature, every input, in addition to just having an overall aggregate statistic. How Arize feels is the best way to troubleshoot model performance in production and how we've done it for teams is first the monitoring aspect, but then actually being able to evaluate individual inputs, individual slices of data to see how that's related to overall performance, and then evaluating those slices. Once you understand the causes of performance degradation or causes of any fluctuation in performance, you can begin to fix the data and ultimately improve your model performance. So I spoke about models with fast actuals, because if models have fast actuals, you can monitor the performance in production. But what about the models that you have that don't have fast actuals? So these are ones where the actuals are delayed. There may be few to little ground truths. Or like biased or partial actuals. So what do you do in those use cases? Well, a lot of teams will use drift as a proxy for performance. So being able to monitor for drift as a proxy is really important to helping teams understand, if their model landscape is changing. So what exactly is drift? Well, drift is a change in a distribution over time. The models we're looking at aren't static, so it's important that your models stay relevant. The main types of drift that teams tend to track for are overall model drift, which is a drift in the predictions, data drift, so any drift in the features, the inputs, and then what's known as concept drift, which is a drift in the actuals. So if you do have your actuals back, you can look and drift in your actuals as well. Why do we actually want to monitor for drift? Well, as I mentioned, it's the best proxy to performance until you get those actuals back. So being able to identify when you want to retrain your model based on the data or model drift is really important. Here we're seeing an image where there's a new input. So if you have a new input in production and your model is not trained on that input, it's impossible to predict how the model is going to respond to that. So making sure that all that is accounted for. In terms of the insights you get from measuring drift, probably the most common distributions that we see being compared are the training versus production environment, where you establish your training as a baseline distribution, and then all incoming data in production is referenced to that training set. It's not limited to just this, any two data sets can create two different distributions and you can measure against that. So different A/B testing, challenger models, training versus validation, more of an experimental workflow are all ways that you can measure drift. And in terms of the actual metrics used to calculate drift, just like with performance metrics, there's a lot to choose from. It's going to be use case dependent, but the three most popular tend to be PSI, which is a population stability index, KL divergence, and Wasserstein distance. And just kind of briefly going into those just to understand the differences. A PSI score is a statistic that measures how much a variable has shifted over time. It's probably the most common method we see for measuring drift in industry because it's very flexible. It's a symmetric distribution, and it's one of the few that's good for categorical as well as numeric, because it's easier to measure a distribution if it has a basis in numbers versus being something in the categories. It also has a lot of real world applications, especially in the financial industry. KL divergence is also a very popular method. It does not have the symmetric property that PSI has, but it's good if you have one distribution that is much smaller or much larger than another distribution. The last one I just want to touch on is the Wasserstein distance. It's also called the Earth mover distance because essentially it's a metric that measures the work, or the work required to transport a mass, like a probability mass, from one distribution to another. So it's how much Earth essentially do you have to move to put one distribution into the frame of the other. And the way we actually approach, troubleshooting and resolving drift issues is first having monitors in place to measure the various types of drift, being able to see, feature drift, prediction drift, the various kinds, what's triggering, be able to triage those, and then actually begin resolution by fixing the data involved. So the third pillar I'm going to talk about is data quality. So data quality is probably the area that most data scientists, machine learning engineers are familiar with. We do a lot of data checks for data, pre-processed. We want to make sure our data is clean before training. But what I'm specifically going to talk about is data quality checks for models in production. This is going to look different from your normal data quality checks because it's coming in real time and you're making decisions from that feedback. So common issues we see here are missing data, duplicated data, type mismatch. Type mismatch tends to be a big one. And then the ways we can catch this are setting up different data quality monitors, have metadata management, and be able to profile your data, and create data quality reports and dashboards too to surface up these issues. And the reason that you need these best practices in production is because there's not really something telling you like the best way to handle bad data that's in production. It's often handled in just the way that we find the easiest, which isn't necessarily the best for our business. So one method that teams do is they'll drop bad prediction requests. This will keep your model like up and running, but we never want to just drop or get rid of data because it could be critical to business decisions. The other option is, you can set default values, but this could be an issue because you're essentially setting these default values based on what you see in training. So there can be issues there. It also tends to be a very manual process. It might not necessarily be scalable. And then, there's the option to kind of do nothing, which may be the easiest, but may actually cause the most issues in your pipeline. And if bad data does get through, it could impact business decisions. So pillar 4, explainability. This is, I would say, one of like the newer topics, a buzzword kind of like, AI, explainability, AI ethics. What does it actually mean and how do you use it? So explainability is a technique and it's designed to determine which model, feature or combination of features lead to a specific model decision. Now, the key thing I want you to take away here is that explainability has nothing to do with the actuals or like the ground truth that's coming in. It doesn't take into account if a decision was correct, and it doesn't relate to performance because again, it has nothing to do with the ground truth or prediction. It's just figuring out why that prediction happened. So it's figuring out what features are the most important and what led to that prediction. So the common use cases that actually leverage this are regulatory, business analysis, kind of a check for bias. And what we at Arize use it for is actually being able to triage your most important features in terms of drift and performance, because not all features are equal, and by understanding what your most important features are, you can begin to troubleshoot these problems more easily. So how to actually implement model explainability? So there's several different approaches, and it's really dependent on your use case, your model type, even like computational costs, if you have different like AI governance issues, and whether or not you want like a global or local explainability, because there are different types. Just getting in a little bit more to the different types that you see. So a local prediction is a single prediction. A cohort is the average like across a group. And then global is the average like over all predictions. What do I mean by this? So I'm going to give you like a quick example here. So local, that's like if your model rejected a specific applicant for a loan and you want to know why they rejected that specific applicant. Cohort would be more if applicants all under a certain age or within a certain group get rejected for a loan and you'd want to know why. And then the global, which is what we see being the most common, essentially teams want to know what the most important features are for their predictions. So what's globally like what's lending to that decision. And the most common prevailing methods, you may have heard of SHAP or like Shapley values. This is a method that's used to break down individual predictions. So kind of figuring out like how each feature contributes overall to the prediction. So, I mean, this is rooted in game theory. So essentially it's like if you're making a prediction, how much does each player play into that prediction, and kind of seeing like the most important player like maybe on that team. So the way you can think about it. Certain features always contribute more to a model's prediction than others, and so therefore some have a higher feature importance for your model. So when we look at this in practice, like here's a quick example. If you're predicting the price of a home, you put some inputs into your model and you get the prediction. But some of the inputs are going to be more important for your model prediction than others. For example, for a housing price, if you have a high square footage, that might play a big role in the price. If you have a high or low number of bedrooms, that's going to play a role as well. So each factors going to play a role, but some are going to have a higher importance overall than other features. We're actually going to go through an example together. So let's say that you are a machine learning engineer, you're predicting the likelihood of a credit card fraud, and you have features like merchant type, bank, charge amount, and across all the model predictions, you want to know the most important feature that's contributing to those predictions. So we're going to use SHAP and kind of go through this. So for a single prediction, this is what's called a B-swarm plot, but each prediction we'll have each point, and these points are SHAP values for each feature. So this is a single prediction. It's saying like how much the bank plays into the role, how much the origin plays into the role, how much the charge amount plays into the role, and ultimately these are all led to a prediction on if it's fraud or not. So if we start having multiple predictions, we start stacking these up, and eventually we're creating an average of multiple predictions. So we're seeing like how the bars represent multiple predictions, and SHAP values also reveal like the relevance, like if something has a positive or negative influence. So like when we were talking about housing prices, if something has a large number of bedrooms, that's going to have a major impact. The price it last sold for is going to have a major impact, and this is actually a way to triage the most impactful features. And then we get to like, this is the global importance. So this is the positive value based on the magnitude. And now we found that, the largest magnitude, bank, is going to have the strongest indication on which something is fraudulent or not. And that's just like one example of how SHAP values are used. Okay, so the next part I have on here is for the demo. If there's any questions at this time on the presentation part, I can answer those. Otherwise, I'll go right into the demo. All right. Let's see. Okay, great. We've got a few questions here. Starting with Julie. Is there a good way to manage data quality issues apart from using default values, filling them out with averages, leaving them, cutting them? Okay, great question, Julie. Yeah, so with like the best practices there, ideally you want to, see, depending on the exact issue, be able to see what that is, and then correct for it. So an example that we found for a client is, they trained on uppercase states, and all of a sudden they were getting lowercase states into that data. So just by like setting like cardinality alerts, seeing that's an issue, you can go back and retrain your model quickly, like on like either lowercase states, or you kind of establish a best practice that you and your team decide based on that. The key thing is just getting that alert right away, so you can see, instead of just saying, oh, if anything, doesn't look like this, let's get rid of it, let's change it to something else, but knowing exactly what it is so you can make the best decision with your team. All right, Nikki asked a question like, so, I guess some folks are having issues with the audio connection. Nikki asked about the access code for audio connections. I'll let a member of the ODSC team answer that. All right. Great. So we are going now to jump into the demonstration. So here, looking at the Arize platform, so I'm going to run you through quickly like a workflow on performance, and then we can go through additional workflows. If you have other questions, we can answer that as well. All right, so in the Arize platform, when you first log in, you're greeted with the home screen. This is going to tell you information on the model seen live, prediction volumes, model versions live, as well as alerts around performance, drift, and data quality that you will have set. These are the models you and your team are working on. So if I want to, let's go into like a model based on lending decisions. We have a pretty good understanding of that. So when I go in, I'm now seeing the performance over time. So this tells me about my traffic, and then I just have accuracy here. You can use any performance metric you like, assuming that you're getting these actuals back. If you aren't getting those actuals back, that's completely fine. You'd probably just be having more of a drift workflow, which I'm happy to show after this one. So in terms of model health, we kind of just want to map your overall schema. So there's several different ways of getting the data into the Arize platform. But as soon as you get that in, we take information around your predictions, your actuals, and your features, do data quality checks and drift checks around that. And we will set up your monitors around drift, data quality, and performance. So if you're a data scientist, machine learning engineer, you have this set up, and you get an alert to a drop in performance, what's the next step? So I'm going to click into this performance monitor that triggered. You can have access to these through Slack, email, PagerDuty, kind of the easiest way to reach you and your team. But if I go into an accuracy monitor, for example, so this is showing, like where the model is kind of performing well, when it's performing poorly. And a key part here is, it's nice to understand, what's happening, like why the performance overall is lower or gets triggered. But if I want to actually troubleshoot this performance and figure out why this kind of declined at this point, I can troubleshoot that directly. So now this takes us into our performance tab. So we're able to see this performance degradation, see where it goes low here, have information, again, performance over time. And a key part here is being able to do what we call performance tracing. Performance tracing is actually something we're patenting, or like already have the patent for. And when we talk about performance tracing, what's key here is being able to break down the performance at the feature level. So we talked about feature importances in terms of SHAP values. So you can triage based on your most important feature, but you can also triage based on your most impactful feature. And what we say here when we say impactful feature, essentially this is a performance as a function of volume. So, if you're fixing your model and you're fixing a feature on your model that's performing poorly and it has very low volume, it's not going to make a very strong impact on your performance. But here we can actually see, take FICO score, for example, when the model's performing poorly, we have more of, a darker or redder color. When the model's performing quite well, we have, we see a higher volume here. We also see an accuracy of closer to 80%. So being able to see, where your model is performing the best, the function of volume, being able to triage is an excellent way to start figuring out what's going wrong with your model. But if we want to take it a step further, what we can actually do is add comparisons. So if I want to look at the worst performing kind of piece of my data and kind of compare it to where the model is performing very well, we see it's about 45% accuracy compared to 67% accuracy. So we want to know how to get from dataset A to dataset B, essentially. And now we're able to look at kind of at our performance, how they compare. So it's essentially mirrored histograms, like this is dataset A, dataset B. So if we go into the feature purpose, what sticks out to us? There's a few things that stick out, but what sticks out first to me for the feature purpose is this pawn shop loan input. So pawn shop loans, we get that those can be kind of sketchy. So being able to see that dataset A has, it's performing about 40% on pawn shop loans compared to dataset B, which is performing about 67% on pawn shop loans. And now what we can do is actually filter on this. And by that, I mean, we can add it as a cohort filter, or we can exclude it as a filter. And these are just filter views. So, and like actually be able to filter on individual views. Hold on, I clicked something. All right, perfect. All right. Yeah, and being able to kind of go through individually and like see what's happening there. Hold on one sec. I think we might be going through an update at this moment. Let me just choose kind of like a different model here to see, because I think the platform's being updated. But if we were to go to performance again, we do have like confusion matrix as well to overlap with it. But if we compare at a different environment, so just kind of re-going the steps here, you want to compare data set A to data set B, kind of filter in on those, again, like worst performing slices, look into when like the model's at its best. And this is like real-time computation. We're pretty much built for scale, like high scalability, lots of data in our throughput. And then we can choose kind of filter on one individual feature. We could add these by hand as well, but if we want, we can choose to kind of add these filters to both. So again, exclude this cohort like as a filter, and now we're seeing like the accuracy compared from data set A to B. So we have a few percentage of improvements, and that's just one step in kind of being able to start figuring out where that performance is lacking. And those that have used SQL, you might be able to understand here, like just the amount of queries that you would have to go through to kind of get to the point of seeing, if you were to take out an individual slice of data, how that would improve your performance overall. So just by kind of looking at the amount of time spent kind of going from that workflow to seeing, oh yes, I can see, like the worst performing slices, the worst performing cohort, I can filter on that and then try and get, my, that production, that, down spike, I could see how I can get that back to my, best performing slices. And this doesn't just have to be for production data. You can add any versions and do comparisons as well, and be able to add as many filters as you'd like. I think there are a few more questions. Okay, great question here. Lidio, I hope I'm saying your name semi-correctly. Could you please comment more on the difference between monitoring versus observability? Great question. So when folks are in like the market for ML monitoring, they're typically wanting, if we go to our monitors, they're typically wanting monitors in play, which is great. Teams should definitely have monitors. But what I was saying like in the talk about sometimes an aggregate metric, it isn't enough to help you figure out why it's happening. So normally once you get ML monitoring in place, which is always step one, the next step is, oh, I got this alert happening. What's next? Like what's actually going to help me troubleshoot? So that's why like ML observability, which includes like kind of being able to dive into, oh, drift is occurring, like let's dive into drift, let's figure out what's causing that. Same with performance on if I want to troubleshoot and figure out why something's happening, being able to do that. So monitoring is essentially just monitoring. Observing is fully understanding the model like inside and out, how it's in terms of how it's performing in production. Francis has a question too. Does Arize connect to BigQuery? I have models in BigQuery ML. That's a great question. In terms of the integrations, let me start with saying first that with Arize, you don't have to upload the model itself. So that makes it very platform and model agnostic. So we're taking the data that's surrounding the model. So as long as that's in a readable format, you can use a Python SDK, you can use an API, cloud storage, any way that you have the data in for that. So with the models, you're talking about your models are being stored somewhere. Since you don't have to upload the models, like that's not even something that would be like a big issue, just as long as the data surrounding that models is being sent to the platform. We do have like a whole host of integrations, mostly because we're very platform and model agnostic, because you don't have to upload the model itself. Where we kind of sit in at the ML evaluation store. So if you have like your ML workflow, you're going to have tools that are probably based on like model development, model serving, and then Arize comes in for the production aspects. And folks, let me know if you're getting your questions fully answered. I'm happy to go into more detail. Question here from Ricardo. Is the timeline related to production data? If so, how can you have model performance for data in production? Okay, it's the timeline related to production data. So I'll try to answer this. Like, let me know if I understand this correctly. So with the timeline, so we talked about models that have actuals, models that don't. But you know, with Arize, you can put in as much look back time as you like, and as soon as you put your model into production, as soon as that data starts coming in, like the production workflow, that's going to be recorded immediately. So as things are happening, your predictions are happening in real time. So that's, anything around the predictions is happening in real time. And then anything around the performance metrics, as soon as you do get those actuals back, we will link them back to their predictions with the ground truth. Let me know if that answers the question. This one I'm not entirely sure of. Maybe what would help is if I also show, the kind of workflow we were looking at if you don't get your actuals back. So if I now want to have a workflow with, say I have a model in place and I don't get those ground truths back. So, but I'm always getting predictions coming in, and whether it's batch, whether it's real time, it's coming in to the model. It's coming in like and those predictions are made from the model. So if I want to have monitors in place for performance, those are going to require the actuals. If I want monitors in place for drift, those are just going to require like the incoming data and not necessarily like if a prediction was right or the ground truths. So if I look at this prediction drift for the feature purpose, I'm seeing like where high PSI scores are triggered. I'm also seeing brand new inputs seen in our current distribution. So we have our current distribution, which is our production distribution, and then we have our baseline distribution, which in this case was going to be our training set. So being able to see when there's brand new inputs, when there's high high discrepancies in training versus our production setting, and then we can troubleshoot this directly in the Arize Drift tab. So here, looking at drift over time, being able to see when these distributions start to diverge, and when there's new inputs that are seen in our production environment. We can also kind of get this more in like an experimentation mode. So if I want to say, let's go back to like maybe a different model here. So if we go into our fraud model and we want to look at drift experimentation, I can see my prediction drift over time. So this is what's known as model drift, prediction drift over time. And like for here, you don't need anything related to your performance. So you don't need your actuals, because this is your predictions and seeing how your predictions are drifting over time. So any action that your model has in production, like that's being tracked. And this is again our PSI score. So when PSI is over 0.2, 0.25, we're seeing that drift does start to trigger, and then our distributions start to diverge. We also overlay this with traffic and accuracy. So if you have a performance metric, like it could be any performance metric, you can overlay that. Otherwise, a lot of teams won't have this actual back, and so they won't have what's kind of known as concept drift until they get those ground truths back. And kind of how we triage this, we do use chat values or any kind of feature importance values. So we input the feature importance. We calculate drift on each individual feature, and then we calculate this prediction drift impact score. We get that from essentially multiplying the two and telling you which feature is having the biggest impact overall on your drift. So if I go into, I can go into like a different filter here and seeing that, drift is starting to slowly happen over time. We're seeing that these distributions between our baseline or training set and our current distributions start to diverge. So being able to do that, as well as data quality checks. So are the quantiles changing? Is there a spike in percent empties? Is cardinality changing? Being able to kind of overlay all these as kind of checks is really going to help you monitor your drift. And essentially, when you do find brand new inputs, brand new features, drift happening, most likely it's going to be a retraining on that new incoming data. Okay. All right, let's see here. Okay, Ricardo responded, yes, I was thinking about supervised models that need a labeled ground truth. Yes, so if it's a supervised model, yeah, you can always look for drift, like a few different types of drift, but then yes, the performance, would need that ground truth back. What is nice is we do connect those actuals back to the predictions with a prediction ID. And we have a few things in place for unsupervised methods. But yeah, for definitely the supervised approach, the hardest thing for those models is trying to figure out how they're performing when you have no indication, what's happening because you don't have those ground truths back, right? Okay, great. Any other questions from the audience or things you want to see? I know we have a few questions that were kind of put in before the talk that we can go through. I just want to make sure everyone that's here live gets their questions answered. Right, perfect. We'll continue monitoring. Maggie, were there additional questions?
Yeah, let's go through some of these that came in before the session. So the first one was, can I compare the performance of a production data set with a training set?
Okay, great question. So if we'll go back into our fraud model. We'll go into our performance tracing tab. So here I kind of showed how you can compare different performance environments. But you can also compare training environments, different versions of the training. Version control for us is like very important. So any data sets you upload to Arize, you can use them to compare. So I can add, a training environment here. With Drift, it's very easy. Like if you just set your baseline to be your training set, then everything everything that's coming in, incoming data, is being compared to that distribution. But for performance, you can choose training. You can choose different training environments as well. And if you want to, look in terms of more of an experimentation mode, you can also compare it to validation sets as well.
Okay, awesome. The next question was, can I see a drift workflow?
Great. So we went over the drift tab. Again, just like what that workflow looks like. So if my drift monitor triggers, and I can go and click in directly to the monitors that are triggering. Here's a few that aren't triggering, which might be interesting. So this is what you kind of would expect to see, that your current and baseline distributions match up, or your training validation distributions match up. But if they didn't, you'd be able to troubleshoot that directly in our drift tab and see, if there's any new inputs, like what would those look like? If you do have performance, overlaying that with performance, does a performance degradation like line up with drift? Because a lot of times, like what we saw in the pandemic, the model started to drift and then fail silently, like very subtly over time, but the drift was easier to catch. So being able to just be aware that if an environment changes, your model needs to change. But essentially, if a drift monitor would trigger, you would go into our drift tab and be able to figure out the feature and the inputs and the data quality associated with that drift. Okay. Oh, I see we got another question here. Pervez. So the question is, what is the performance overhead of observability on system resources? Great questions, like CPU, memory, etc. So very dependent on the use case and sometimes the type of industry. Depending on, if you're an ad tech company, you might be doing, billions of predictions every day, even higher amounts than that. If you're an insurance company, you might be doing millions a month. So that's kind of the overhead in terms of the prediction volume. For Arize, we are based on a volume kind of pricing model. So for us, it's kind of just how much data are you sending into the platform, and that's kind of where we're looking at. But the background of the infrastructure that we're working with is highly scalable. So that's another thing to consider. Performance overhead is going to be a lot more for observability, depending how that infrastructure is built out, depending how optimized it is. Yeah, that's always the $1 million question, but the answer, unfortunately, is always it depends. So what's nice is ML observability well, actually, for some observability platforms, it does depend on the size of your model, which can be an issue. But for our platform, it depends on the volume of data. So if you have if you're working with very large models, you want to make sure that if you're putting ML observability around it, it doesn't have to kind of utilize that model size in each prediction or each kind of understanding of drift performance, because that would be a very large overhead.
Okay, it looks like we have another question. Can data from the dashboards I create / customize be shared with my team?
Oh, great question. Yeah, I think that probably came from seeing dashboards here. So a few ways of kind of going about dashboards. We can actually create them like at the model level. So I'll just show you how to do this within a model. So say you're working with this lending model, you want to create a dashboard. Are folks here familiar at all with Grafana? Yeah, a few? Okay. So Grafana essentially is, a way of creating like custom dashboards. So we can create these widget dashboards from scratch. We do have a variety of templates as well. Like if we go to our template section, I'm going to create just like a performance scored model here. So maybe like performance, select the model. I can select the versions. I could select the features behind that, kind of the positive class. I mean, these are going to depend on the type of model you put in, but and then we have like our performance dashboards. These are able to be completely reconfigured. They're around time series distribution and stats. You can edit individual dashboards. You can layer these plots as you'd like, kind of at different versions, being able to add filters on top of them as well. So very flexible here. And what's great is like once you're done, you can also decide to maybe make this a plot just for something you're focused on. Like maybe if you're running points in California or kind of the West Coast states, you can create dashboards just for you to kind of surface these insights. You can also export these. So now this dashboard I made, it can be found here. This is the one we just made now, this performance dashboard, and you can highlight those insights to various stakeholders. It's really nice too if you just want to put like everything you found maybe into a presentation, maybe into something you could just export, send in an email, and be able to highlight those. These are also, you can edit and change these within teams, so I can work collaboratively on a dashboard with other team members.
Great, and it looks like Francis had a question about, does it have alerting capabilities in real time? Or are we able to set up thresholds for the alerting?
Okay, yeah, I see the question. Yes. So yes, like for the monitors. Okay, I'm gonna go into monitor and just show, but yeah, alerting capabilities in real time. So like as data is coming in, as soon as something triggers, you would be sent that alert to either Slack, email, PagerDuty. Those are the main ways that we reach teams. If you wanted to say set up a new monitor, let me just show you how to do these, because all the monitors actually are configured automatically. As soon as you get your data into the platform, you go through like 3 different questions like for your setup instructions, and then all these monitors are automatically configured. That's why we use like a PSI score, because we configure every monitor on every feature. So that's, you know, a monitor on drift, performance, and data quality for every feature, but then you can also add, customize as many monitors as you want. So say I wanted to create like a data quality monitor, I can, you know, change out the name, change out the version, kind of the dimension in terms of like, do I want it over like the feature space? You know, I could have them set for predictions, actuals, different kind of metric types, filters. So you, again, like individual, if you want to set like even a combination of features, you can set those as well. You can have an evaluation window, but that's the duration like over which the metric is calculated. This would be like a real time thing. So you could change the evaluation window, but no matter what, like as soon as a thing of data would come in and meet this criteria, you'd get alerted to it. So you'd be able to change out also like the trigger alerts, and again, like where this alert is sent to. So this is also a way you can divide alerts between teams, because all these monitors are set like for certain models. They update as you update the model as well. So you can also just change out like who gets what alerts for what models. I see a few more questions. Maggie, I got these ones. I'll go through. Okay, great. Yeah, and folks, I'll actually ping to a poll here in a minute, because if you're interested in having like a further conversation of this, we'd love to talk with you more. And we'd also be happy for you to join like our community Slack. I'll tell you about that in a moment. I'll just get the rest of these questions answered. Francis, also a lot of great questions here. And the next question, like around alerting, are you able to set thresholds? Okay, so I think yeah, I know you already asked that question. But yeah, you could set your alert metrics, and you can also do this for drift performance, be able to kind of set that thresholding alert as well. Normally it's a lower limit, or it's like it's a limit, and you can set multiple monitors if you have like multiple states you want to look at. Pravez asked a question, is there an automated response to alert without a human in the loop? A lot of that is set up not so much with like the Arize platform, but we do integrate with Amazon Event Bridge. So some teams have it set up like if they get a certain alert, it will trigger a retraining cycle. So yeah, it kind of depends, depending on the alert, what you'd want the process to be, and then the tools you're using can set that up. Okay, so I'll continue monitoring that for a minute. Just want to get in here. So like I want to thank everyone for joining. We'll still keep asking a few questions, but I just wanted to mention this free event. It's the Arize Observe, so it's the Machine Learning Observability Summit. Again, completely free, a bunch of amazing talks. It's March 29th. It's a fully virtual event, and there's going to be ways for you to get your hand on the platform, you to go through different processes, playing around with the data, and then we have a lot of folks, from just amazing companies and teams we're working with, giving talks on like the best practices. We have this really interesting panel like on like embeddings, the embedding space, how to measure that. So we actually have the founder of UMAP and a co-writer on TS&E, like kind of talking it out. So yeah, definitely check that out.